Okay, welcome DS25 to day 2, module 2. We're going to still be working with pandas today and exploring data sets, but we're going to be doing some new operations today. We're going to be doing something called feature engineering. All right. Feature engineering just means we're going to take the columns that we have on our data set and use them to make new columns that weren't there before. And these new columns that we make, we hope will express the information from our data and the patterns in that data in new and interesting ways. And if we successfully do this, express those patterns in new ways, then these new columns that we generate could, in the long run, help our machine learning algorithms be able to detect patterns to data and then ultimately be able to make better predictions, right? So today we're just focused on the operation, the pandas specifics of how do we work with individual columns? How do we make new columns? All right, we're not going to be using any machine learning algorithms today, but once we get to the end of Unit 1 and the beginning of Unit 2, you'll really see that these fundamental skills of working with columns and making new columns are one of the most effective ways to improve machine learning algorithms. So that's why we're starting with it. Day 2. This is a kind of a big topic and something that we're going to keep on doing throughout the whole rest of the course. So let me share my screen. And I have already shared a version of the lecture notebook with you in the DS25 channel. And I've also opened up a question thread. So keep an eye on that. We are going to use that here in just a moment, right? So I want you to understand, okay, what is the purpose of feature engineering? What are we doing here? And then I want you to be able to do feature engineering, particularly when columns in our data set hold string data, all right? Strings can be the trickiest kind of data, one of the trickiest kinds of data to clean up and to make usable. Oftentimes, we're wanting to take that string data and turn it into some kind of quantitative or numeric representation. Again, referring back to some of the ways we talked about our variables and our columns of our data set yesterday. Right? And we're going to very briefly show you that we can also take string data that represents dates, right? Month dash year dash day, or month slash year slash day, or something like that, and turn it into a date time object, which is a pandas specific feature. And then we can very easily manipulate those dates, calculate the amount of time between two dates, for example. It's just a useful thing if we ever have data in our data set that is representative of some kind of dates, right? Now, we'll also be reviewing something called the .apply function today, which is a fancy pandas method of making a new column on a data frame. All right, so we're going to try and really focus on this one. I think this is going to be the most difficult. Excuse me, I didn't mean to double click that. I think that this objective will be one of the most challenging ones today. Getting really your head wrapped around how that .apply function works is going to be what I really hope to help you come to terms with here during our discussion. So one thing you're going to see today, and one thing that might be a little bit frustrating over the coming week, is centers around this concept, the concept of something being what we call Pythonic. All right. Any guesses or any ideas about what it means for something to be Pythonic? Let me know in the question thread. Pythonic. Hector says only works with Python. Good thinking. Yeah, I see this root word of Python, so it has something to do with the Python language here. Curtis says that it uses Python syntax. Kaji says when it doesn't duplicate, so smart code. Sometimes we call that code dry code, and that it's efficient and it doesn't repeat itself. DRY stands for don't repeat yourself. Good, good, good. So there's elements of Pythonicness to many of the things that you guys have shared, right? Pythonic means that some particular library or code follows some of the guiding principles of the Python language, right? So let me even see if I can Google this here. There's an expression here. Okay, so the principles are listed as follows. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules, etc. Right? So this is the Zen of Python, as it's known, right? And it keeps on going, other things, right? But the Python programming language was created with very clear like intentions to how it should be expressed, and how we as the users of Python should go about doing things, right? So if something is Pythonic, then that means that code gives us one clear way of doing things. One clear way of doing things. Okay. Now, when I say that pandas is not Pythonic, okay, then that means pandas as a library kind of contradicts some of these rules of elegance and simplicity that were intended to be baked into Python, right? So what you're going to find today, right, is that, let me put this, Pythonic means that there's one clear way of doing things, right? With pandas, there is not one clear way of doing things. There's often multiple good ways of doing things, multiple acceptable ways, multiple useful ways, all with their little pros and cons, okay? So you're gonna see here that even today, I'm gonna show you 2 or 3 methods of generating new columns on a data frame, all right? Now, the one I really want you to focus on is the .apply function. And another one that I'll try and call your attention to here as we're working. But don't be frustrated if you feel a little bit today and in the coming days that, man, Pandas has so many ways of doing things, I can't keep them all straight. What I encourage you to do is to focus on just one way that works for you in the beginning, and then always use that method until it's second nature to you, right? And then as you get comfortable with that one method, you might branch out and learn more than one way of doing things, right? But don't be worried if you get a little bit confused and you have to review things or you have to refer back to your code. Pandas is not Pythonic, and so sometimes it can be a little bit frustrating in that sense. Good. Logan is on top of it here and gave us a good summary there. I'm sorry, Logan was probably still typing out his answer, but he hit it on the nose there in the question thread. Yeah, one clear way of doing things, and you can read up about the Zen of Python if you're a little bit more curious about this in general. I'll share that in the channel. Okay. So with that being said, let's talk about feature engineering, this thing that does not have one clear way of doing things. And first we need to import the library we're going to be using. We're going to import pandas as PD, alias it to this new variable name PD, okay? And these 2 lines of code, I'm actually going to comment them out for a minute. We'll come back and fix these once I show you why they're here. All right, so we're just going to read in pandas, and then we're going to read in this data set. The link has already been given to you, okay? And we're going to save this under the variable name house. So that's going to be our data frame. This is actually housing data from Ames, Iowa, all right? And it's a very common kind of housing data set, but you're going to see that there is kind of a lot of data here. There's a lot of columns here, right? So we could do house.head if we wanted to look at the first 5 rows. So that's something we learned yesterday. And you'll see that we're seeing 5 rows now, but that this data set has 81 columns, okay? There's a lot of columns on this data set, right? You may sometimes hear columns of a data set referred to as attributes. Now, the reason for that is that each row represents a different house. And then each column is a different attribute of that house, right? Whether or not the street in front of it is paved, if there's an alley next to the house. I'm not even sure what all of these represent exactly. Is it a 1-story house? Is it a 2-story house, 1-story house? Is it a single family dwelling? What year was it built in? What year was it remodeled? Like, there's so many things here, trying to just summarize every aspect of this house. Now, what this data set is primarily used for is the prediction of the price of the home, right? Can I measure through all these qualities, all these attributes about the house, determine what it will be sold for, right? Or kind of do an appraisal here with data and get its appraised value, so to speak, right? And we can actually get pretty accurate with this. That's not something we're going to be doing today, but I just want you to see that we have lots of different small pieces of information about the house, and that each row of our data set represents a different house. Okay. Another thing I'll point out here is that as we scroll through these columns, see this ellipses here in the middle? We sometimes call this truncation, meaning that some of the columns are not being shown to us. There were so many columns that our notebook said, whoa, this is too much information to display. I'm just gonna take some of the middle columns out, which is kind of problematic if we wanted to look at those columns and see what they had, all right? We will see the same thing here if we do house.tail. We'll see the same truncation there, if I can find it. Okay. And also, if we do something like this, so we want to get information on each variable. So if I say house.info, right, that'll give us information on each variable. It's kind of long. It's a lot to scroll through. Okay. You can see that we have a lot of text data with the object data type, but we have also some integers and floats here. Kind of got a mixture of many different data types. And this is a lot of columns to deal with. We're going to, in a minute here, narrow it down to just a few columns so that we're not fighting all of these extraneous pieces of data that we aren't really interested in. Okay. Another thing I'm going to show you here is, imagine we just wanted to look at one of the columns. Let's look at lot area. What's the size of the lots? And it's probably in square feet. So house, right? My square brackets say, get me a portion of a data frame. And the portion that I want is the lot area column. Okay. Now take a look at this. This says that it's trying to print out 1,460 pieces of information here, meaning that we have 1,460 rows in our data set, right? Again, we could also use little review from yesterday, the .shape command to see the number of rows and columns, right? So 1,460 rows, 81 columns. There's a lot of data here, is the moral of the story. Okay. And we also see some truncation here happening when we try to print out lots of rows of data. It says, hey, I don't think you really meant to print out 1,460 rows here. You just wanted to kind of glance at your column. So I'm going to try and be smart for you and limit how much you can see. Okay. This is a default behavior of pandas, and this is due to what we call pandas display options settings. So there's some settings within pandas that will determine how much data will be printed out if we have a whole bunch of it, right? Because imagine we had, as we'll work with in a few days, a data set with 3.4 million rows, all right? And you wanted to print out one of the columns, and every time you wanted to look at one of the columns, it tried to print out 3.4 million pieces of information. That would take a while. It would slow up your computer. It would take up a lot of RAM in your notebook memory. And if we use too much RAM, your notebook can actually restart. It will crash. And so Pandas here is trying to do us a favor in a lot of ways. But for us with this data set, we're saying, you know what? I want to see these columns, right? Please let me actually look at these columns. So that's what these two rows that I mentioned that are commented out, that's what they control. Okay. So if I want to be able to see more rows or more columns, I could say, hey, pandas, please don't truncate. Please don't remove those columns unless I have more than 100 columns. That should be the maximum amount of columns. If I have 101 columns, it will truncate. If I have 99 columns, it will not. All right. So we'll set that. And we're also going to do this for the number of rows as well. If I'm ever looking at less than 50 rows, don't truncate. Okay. So what this will do, I'm going to rerun some of these cells here, is now I can see all the columns. There's no truncation because we only have 81 columns, and that's less than this max value, right? So we're not seeing any truncation with the columns. However, so keep on running some cells here. Here with lot area, I am still seeing the truncation. And why is that? Well, because we have 1,460 rows, but my max is 50. All right, so if I wanted to see everything here, I would have to set the display options to something like 1,500, okay? And then I could see all of the lot area rows. But again, this is a big output. It's kind of gross. You probably don't want this, but it is a possibility. All right. One thing I'll also show you is that if the output of your code cell ever gets really big and it's kind of making it hard to scroll through your notebook, you can come and click on the 3 dots here on the right-hand side and say clear output. Now that doesn't change, doesn't erase your code cell, right? It's still here and my code cell's still executed. It's just kind of removing that white output section below the code cell. So sometimes that can be a convenient thing to do. In fact, I might even do it here. Actually, I won't, because we want to have this for viewing a little bit later. Okay, but I'm going to put this back to something like, I don't know, 100 rows. And by the way, if you do Shift Enter, that is a keyboard shortcut for running whatever cell you have selected. So if you just hold Shift and hit Enter a bunch of times, it will go just down to the next cell over and over again in your notebook. So if you see me running code cells without physically clicking the play button, it's because I'm doing Shift Enter. All right. Okay. So let's get on with this now that I've explained those display options and we're working with a little bit bigger data set than we worked with yesterday. All right. What if we just wanted the data types, like say house.dtypes? Okay. And now I just have the data types column again, integers, objects, and floats. It's kind of the different kinds of pieces of data we have here. And if we wanted to look at missing data, we'll do df.isNull.sum. This is again something we looked at yesterday. Oh, I'm going to do this a lot. I use, sometimes my brain just automatically goes df, even though we named our data frame house. All right. You can see here that some of these columns have a lot of missing data. Right? One of the biggest ones is the pool QC. That's probably like the pool quality or something like that. Why do you think so many of these houses are missing information about their pools, right? Why is so these null values, which are represented using something called nans, we'll talk about those more today, right? This detects them, says, hey, we've got 453 of these rows, don't have any information about the pool QC. What do you think is going on here? Why do we have so much missing data when it comes to this attribute of the houses?
They don't have pools.
Yeah, they don't have pools. This is Ames, Iowa, after all. This isn't Florida or some other place where lots of people have pools. Yeah, this is not really data that's missing. It's not like someone accidentally deleted it from our data set. It's that this really is an attribute that is not applicable to many of the homes, right? Same thing, many homes don't have fireplaces. So they can't have a fireplace quality if they don't have a fireplace. Basements, some don't have basements, right? So one thing I want you to think about, oh, many don't have alleys next to their homes, right? So missing data is not always a bad thing. And sometimes missing data can tell us important things. It doesn't always mean that data has been omitted or left out, but it sometimes means that there's an attribute that is just not applicable to that row or to that observation in our data. Okay, let's look at the number of missing observations in the entire data set. Oh, we need another dot sum here. So this tells us one single dot sum tells us per column. And if we put another dot sum on the end, it will tell us for the entire data set. So there's somewhere 6,965 pieces of information that we don't have about these 1,460 homes. All right. So on average, each home has somewhere around 4 to 5 pieces of missing information that was not applicable to that home. All right. Again, descriptive statistics. For our numeric variables, we just do .describe. We can see the mean, the standard deviation, the median, right? And these counts will change if we have missing data, right? So we had some missing data here with lot frontage, so the count is not 1,460. Similarly, if I find the basement and the fireplace stuff here, which may not even be here, because they may not be categorical variables. Some of these do not have a full count because there's some missing information in these columns. Okay. Also, we can exclude the numeric columns and only do this for the categorical columns. And what did I do wrong? Oh, I spelled exclude incorrectly. I should have a C here and exclude. And now we see some of this information for our categorical data, or as we sometimes call it, our discrete data types, right? If there's a specific number of, a countable number of values that could appear in that column. For example, you want to look at the frequency here and look at a frequency that's not very high. A lot of these frequencies are pretty high. Pool QC, there must be 3 different pool qualities: good, fair, and bad, or something like that. So that's a good example of a categorical variable here. All right, so a little bit of review yesterday. This is one of the things we're going to do. The first time we load a data set is dive in and see if we can learn a little bit about it using some of these basic pandas methods. All right, now we are going to look at some specific columns, and we're going to then slim our data set down to make some new columns, do our first example of feature engineering here. All right. So let's look at the bedrooms above ground column. One thing I don't like about this data set is that they've got funny capitalization in their column headers and abbreviations as well. So sometimes it's a little bit tricky, but this is bedroom ABV GR with a capital A and a capital G. That's bedrooms above ground. Okay. And most houses looks like they have around 3 to 4 bedrooms. Okay. I'm just making that assessment here. Again, we could do a value counts on this column and see, okay, yeah, most houses have 3 bedrooms. Then the most common is 2. Right. There's one house in this data set is up to 8 bedrooms. Okay, pretty big house. There are 6 houses that have 0 bedrooms, which is odd to me. So that might be something we would want to investigate here a little bit more. Right. But value counts, again, we can count up the different instances of different categorical variables throughout our data set. Okay. So I kind of spoiled this by my talking, right? But is bedroom above ground, is it categorical? Is it quantitative? Is it ordinal? Is it, what are some of the words we can use to describe this bedroom above ground column or attribute? Is it an identifier variable? Okay, it's quantitative. Good. That's because it's represented with numbers. You can also sometimes say numeric. Because numeric and quantitative are kind of synonyms. What else? Okay, it's definitely categorical, right? We have 7, right? 1, 2, 3, 4, 8 categories here. Different options that could have shown up. Okay. Is it discrete or is it continuous? Is it discrete or is it continuous? Good. Ben says it is discrete, right? Categorical and discrete are kind of synonyms for one another, right? Discrete means there's like a countable number of options, and I can definitely count up to 8. All right. So we're good there. Another word here we can use to describe this column is ordinal. Ordinal means that there's an order to it. 4 bedrooms is more than 3 bedrooms. And I can say that definitively, right? I could sort these from the most number of bedrooms to the least number of bedrooms, right? If there's a way that you can sort the column or order them from least to greatest, right? Then we say that that is an ordinal variable as well. Okay, so lots of terminology here. They mostly mean the same things. Is it represented with numbers? Is it categorical or not? And can it be sorted or not, right? And then a whole bunch of fancy words to say those, to express those concepts. Good. Excellent. So let me just make a quick list here. Categorical, it's quantitative, it is ordinal, it is discrete, and it is numeric, right? But that's really kind of the same thing as quantitative. And discrete is kind of the same thing as categorical. Okay. All right, let's look at the lot frontage column. We're not going to take quite as long for the lot frontage column. I just want to point out something that will be valuable to you today and on into the future. So here's the lot frontage column. This is the length of the street facing part of the house. How long is that side of the lot in feet, right? So if you were to measure the length of the lot on the street facing side, that's what the lot frontage here is. And you see a whole bunch of whole numbers here, 65, 80, 68, 60, 84. However, the data type of this is represented with floats, right? So we have these decimal portions, 0.0, on the end of every number. And now the question that I have on them is, why are these values being stored as floats if what I'm seeing here, at least initially, is that all these are actually whole numbers? Why store them this way if we don't need, if there's no decimal portion that's been measured about these houses? They've all been measured to the nearest foot. Well, let's first confirm to ourselves that indeed everything in this column is whole numbers. So we'll do a value counts. And we have 110 here. So I'm going to go up and I'm going to change my display settings here to 120. That way I can see the whole value counts. Okay, there we go. And we see here on the left-hand side, 0.0, 0.0, 0.0, 0.0. This is faster than scrolling through the whole data set, right? Everything is a whole number, okay? I'm going to show you why this is, and it might be something you hadn't thought about a whole ton, okay? Here in the value counts, there's another parameter I can pass. I can say drop NA equals false. And this will now show me the number of homes that don't have a lot frontage. Maybe they don't have any piece of their lot that is facing the street, okay? And it looks like 259 of these homes don't have any lot frontage, okay? So that was not an applicable attribute to 259 of these houses, right? So the missing value indicator in pandas is this symbol. We call it a NaN, NaN. NaN, it stands for not a number, and it basically just means something went wrong. There's something missing here. This is a null indicator about, you know, that this code cell is messed up, or we just don't have the data, right? We typically don't want them. NaNs are not helpful. They're a little bit helpful, but they're usually not very helpful, okay? But there's something that's interesting about these NaNs, okay? Oh, I was going to also, I was going to do the drop NA down here below. So I'm going to leave this as just a value counts. And then I'm going to add the drop NA down here. Okay, so now you can see both versions, both with and without. It's really just the same thing, but this doesn't have the NaN values at the top, whereas this one does. That's the only difference between those two value counts. Okay, so we're going to import a library called NumPy, okay, as NP, okay. Now NumPy is a library that's kind of working under the hood of pandas. Our data frame and our data frame columns are all actually stored in what are called NumPy arrays. And this NaN object actually comes from the NumPy library, which is why I need to import it here, because I want to show you what the data type is of a NaN. Okay, so if I do np.nan, let me just print out a NaN for you first. Okay, you can see it's kind of what they look like. But this is what is filling up all those cells in our data set where we have missing data. It's just NaN, not a number, something went wrong, missing data, right? That's what it's saying to us. What do you think the data type of a NaN is? Do you think it's a string? Do you think it's a float? Do you think it's an integer? What do you think? Okay, Andrew says float, Devin says string, Kaji says object, Jerry says string. Okay. I mean, it's letters, right? How could it not be a string? Yeah, and Ben makes a good point here. NaN stands for not a number. So maybe it's not a numeric data type. Okay, this is a little bit silly, but a NaN is a float. You say, what? I say, I don't make the rules. This is what NumPy says it is. All right. So what's really going on here with our lot frontage column is that we have floats, NaNs, we have 259 floats in this column of data. And then we had all these other integers. In fact, if we were to go and look at the original file, the original CSV, all of the lot frontage columns are indicated as integers. All right. But then when we read in this data set, because there were NaNs in this column, everything got changed to floats. Okay. So here's the short explanation that I've been building up to is that because the data type of a NaN is a float, Pandas wants to try and keep a consistent data type throughout the whole column. All right. And so it has actually changed all of our integers to floats so that they will all match. It can't change a NaN that's a float to an integer. So it had to change the integers to floats, right? It's just trying to keep consistency within our data set. So if you ever see a column that's represented with NaNs and you say to yourself, why is that column represented as floats? You say to yourself, why does that column have floats in it? That doesn't make any sense. It's probably because there's some missing data somewhere in there. And NaNs have been inserted as placeholders for that missing data. And then the Pandas changed the whole column to floats. Okay. So this is something I need you to know about NaNs because there's portions on your assignments in the coming days where we're going to say, make a column of integers. And if you accidentally put even one NaN in that column of integers, it will not show up as integers. It will show up as floats. You have to remove all of the NaNs or not put any in order for that column to be actually act as integers and to be represented as integers. Okay, kind of a quirky thing about Pandas and about its kind of a sister library NumPy, which is doing a lot of the hard work behind the scenes. In weeks 2 and 3, we'll talk a lot more about NumPy and we'll use NumPy arrays more specifically. For now, we're just going to work with data frames and data frame columns. Okay. Now that we've kind of dived into this data set, we've reviewed some things from yesterday, let's take a 5-minute break. And when we come back, we're actually going to pick just a few columns of this data set and show you our first example of feature engineering. So see you back here in 5 minutes. Thanks, everybody. All righty. Come on back. We'll get going again. Sorry, CT, I missed a question by CT in the question thread here. I want to address that really fast. Okay. He asks, by default, does value counts produce descending ordered values? Yes, that is the default behavior here, right? So you'll notice that everything is sorted here based on the counts. Whatever value happens the most often is here at the top. So it looks like most houses, or the greatest number of houses have a lot frontage of 60 feet, right? But I can put inside of these parentheses here. If I type these parentheses and I leave my cursor inside of it, it should pop up a little window for me. Come on. Sometimes it does it and sometimes it doesn't. All right, so let's look at the documentation. Value counts, I didn't even spell pandas right, but it still knew what I wanted. Okay. So there's a couple of ways to sort it. You can say sort ascending. By default, ascending is set to false. Right? We used drop NA. So if I take ascending and set it to true, right, then it will reverse it. And now 60 is at the bottom. Now it's in increasing order. Right? So I can change the way it's sorted based on the values. I could also set it to be sorted based on the index if I wanted to. I'll leave that to you to look in the documentation if you're interested in. But yeah, this is kind of the default behavior, if I take this out, is to have it in decreasing order. All right. Good question. All right. So to show you an example of feature engineering here, I want to grab some specific columns here, right? So remember, I can grab just one column by saying the string of the column header here, total basement square footage. Again, kind of annoying capitalization here. So if you get something that looks a little bit different than me, double check your capitalization and the abbreviations here for the column headers. So this is the basement square footage. If I wanted to get more than one column here, instead of passing in just the individual column header, I could pass in a list of column headers, right? So lists have to start and end with their own set of square brackets. So I'll have a list of total basement square footage and first floor square footage. Okay. And then I'll get 2 columns. Okay. This, what you're seeing right here, is what we call a pandas series. Series is just the technical name for an individual column. And you'll notice that when we're working with the series, the output here is just as plain text, right? And we see the row index, the row numbers here on the left-hand side, and then the actual values as the second column here. Well, if I select more than one column, then what I actually get here is a data frame, a 2-column data frame. And it's like a small version of my bigger data frame. And you'll notice that it's a data frame because we get this fancy table formatting, right? So this is a series being outputted. This is a data frame being outputted. Okay. And what I'm really doing is I'm taking a list. Whoops. Let's undo that. Okay. Copy this, right? Something like this. Here's the columns I want to get. And then I'm putting that list inside of the square brackets. Right. So this expression right here is equivalent to me just taking that list and putting it directly inside. All right. And that's why we get 2 sets of square brackets on either end here. Right. One set of square brackets says, get inside the data frame and get me a portion of it. The other set of square brackets are the bookends for our list. Okay. Same thing. All right. What I want to do here is I want to make a smaller data frame with only a few columns, 4 specific columns. All right. And I'm actually going to share some of this code with you because it's kind of a pain to type out. I'm going to copy and paste it. You should be able to copy and paste it, right? But I just hate typing out these column headers with this data set, right? So we're going to have the total basement square footage, the first floor square footage, the second floor square footage, and the sale price. And we're just going to look at these specific attributes of the home. And now this dot copy on the end, what that will do is it will say, okay, instead of just looking at these 4 columns inside the other bigger data frame, let's explicitly pull them out, make a fresh copy of everything, and we're going to save that fresh copy to this new new data frame called small house. All right. If I don't put this dot copy on, you're going to get an error that's generated, and I'll show you what that error looks like by leaving dot copy off for now. Then we'll come back and put it back on in a minute. Okay. So here is my new data frame, small house, but this actually isn't a new data frame yet because I took the dot copy off. This is us looking at the 4 columns in the original house data frame, right? It's kind of like we're looking through a window here into the previous data frame and just peeking at these 4 columns. Okay. I'll explain what I mean in a minute. So again, let's look at the data types. And you'll see that everything here is represented with integers. Okay, that means we don't have any missing data, because if we had a nan in any of these columns, the columns would be represented as floats. So that already tells me that I've got good data for all of the rows across these 4 columns. Okay, and this is the first method I'm going to show you of doing feature engineering. In other words, making a new column, the thing we're really here for today. Okay, and I'm going to say small house, and I'm going to make a new column called total square footage. Okay, that's going to be the new column that I'm making. Whenever I make a new column on a data frame, I have to use something called bracket notation, meaning I'm going to tell pandas what I want the new column header to be by putting it inside these square brackets. Okay, this is the same notation we would use when we were trying to access a specific column, but this column doesn't exist yet, right? So this is me just telling pandas, hey, we want to make a new column, and I want that column's name or the column header to be total square footage. Okay, and then we need to assign something to that new column. And what I'm going to assign to it is small house total basement square footage. And I'm going to add to that our small house first floor square footage. And I'm going to add to that our small house second floor square footage. Okay. And if I haven't made any typos here, it should run, and it did. So if we look at small house now, let's actually do it here. I'm gonna make, oh no, did not mean to click that link. Okay, small house dot head. Okay, you can see I now have a new column called total square footage. Okay, and this is a piece of information that previously did not exist anywhere in my housing data set, right? There was no column that represented the entire square footage of the home. I just had the square footage of the individual floors, right? So already this total square footage is new information that I generated using some of the other columns as kind of the precursors to this total square footage column, right? But you'll also notice we got this funny error message here, right? It says, setting with copy warning. A value is trying to be set on a copy of a slice from a data frame. What this means is that our new small house data frame is not a fresh copy. We're really just looking kind of through a window here at these columns, but the true home of these individual columns is back in our original house data frame, right? So we have not broken the link between our original data frame and made a completely fresh new copy. That's really what this error message is telling me. Now, there's multiple ways with dealing with this error message. One of the most common ways is just to ignore it. At the end of the day, it's a warning, right? It's just a warning, right? Setting with copy warning. And this warning is actually somewhat controversial among the maintainers of the pandas library. Some people want it to be removed. They're like, what's the big deal? I'm going to show you that if ever you get this warning, think about, okay, when am I trying to make a new data frame or take a portion of a data frame? Oh, well, that was way back up here when I took house and created small house. If I explicitly make a fresh copy of my data frame, when I break away and make this smaller subset of the data frame, okay, then my setting with copy warning goes away. Okay, so calling .copy is going to make that warning not show up. So you don't technically have to use .copy, and it's something that it's going to take a little bit of practice at spotting when it could be used. But that setting with copy warning is a good indicator that there might be a place above where you're working that is suitable for using .copy. All right, so now I know I'm working with a completely new, fresh data frame called small house. Okay, we are going to make another column here called price per square foot, right? So I'm going to put this on the small house data frame. Using bracket notation here, I'm going to indicate that I want this new column to be called price per square foot. All right. And then what do you think I should do in order to calculate the price per square foot of each home? What do you think I should do? Up here, I just added some columns together. What should I do with my columns here to generate this new price per square foot column? And don't be afraid if someone beats you to the answer in the question thread, you can still type it out. But yeah, that'll happen sometimes, whoever's fastest on the draw, okay? Kaji says we want to take the sale price and divide it by the square footage. Yeah, so that word per is an indicator that there's some division happening. Price per square foot or price divided by square foot, the square footage, right? So we'll take small house sale price divided by small house total square footage. And then we'll do small house dot head. Okay, here's our new column, price per square foot. One thing I want to point out is that the price per square foot column got added all the way over on the right-hand side of our data frame. Whenever we make a new column, it's always going to be put all the way over on the right-hand side. Okay. So if you're working with a really big data frame and you create a new column, you may have to scroll over to the right a bit to look at it and make sure that it's there. Okay. Now, this price per square foot column is even more useful than the total square footage column. What does a high price per square foot say about a home? What does having a high price per square foot say about that house?
It's in a nice area.
Yeah, it's in a nice area. Maybe this is beachfront property in Ames, Iowa. Maybe it's overpriced. Yeah, maybe just someone thinks they can get more out of it than they really can. Maybe it's got nice schools around it. Maybe it's been made of high quality building materials. Maybe it has a really big lot, right? Because this is just the square footage of the home itself. We're not taking account lot size, right? So this new column really is revealing things about these homes that was not explicitly captured in any of these previous columns, right? There's nothing about the first floor that necessarily says the quality of the building materials or the quality of the schools around. It's just a measurement, right? And some of these things are very implicit, right? The sale price maybe tells us a little bit about the quality of the home. They would be correlated, but this is a little bit better measure. Okay. Also, a low price per square foot says all the opposite things, right? Maybe it's made from cheap materials. Maybe it's in a bad neighborhood. Maybe it's around undesirable schools. Maybe it's got a small lot, etc. Right? So just think about all the patterns in the data that can emerge from this column and all the new things it says about our homes that are not necessarily captured by the previous columns. What's really cool here is I didn't have to go and send out a survey or anything like that. I created this new column using data that I already had. And so this is what we call this feature engineering. Feature is another synonym for a column on a data frame. So we've got columns, attributes, features. Those all mean the same thing. We just engineered a new column on our data frame. We just engineered a new feature that captures patterns in this data in new and probably interesting ways. Right? So that's really our goal. And if we had this column on a data set, we might be able to detect patterns in the data a little bit better. All right. So why might you want to have the total square footage or price per square foot variables, right? They say things about our houses that aren't directly captured by the other columns slash features slash attributes. Okay, lots of synonyms here, right? And so like new patterns in the data can arise from this new column and help us make better predictions, which is really what we're all about when it comes to machine learning. We want to make as accurate predictions as possible. Okay, so this is an example of feature engineering. It's a really simple example. We're just literally taking one column and dividing it by the other. Okay, but I want you to remember, this is something that's really important. Whenever you're making a new column, you have to designate the new column header using bracket syntax. Okay. Here is another way of making a column. Yet again, not Pythonic. Multiple ways of doing things. Okay. Multiple ways of doing things. We're going to use something called the .loc command. All right. So say I wanted to make an indicator variable for if whether or not a home had a high price per square foot or a low price per square foot. Okay. So maybe if I do a small house, I'll do this above, small house dot describe here. Okay. And the price per square foot, the average is around 70. Okay. So if we have a price per square foot that is 70 or higher, I'm going to say that's a high price per square foot. 70 or lower, I'm going to say that's a low price per square foot. And we're going to separate these into two different categories. Okay. So what I'm going to start with is I'm going to take my small house and then my price per square foot column here. I'm too lazy to type out the column headers, okay? And I'm going to compare that to 70. So if that is greater than or equal to 70, I'm going to compare everything in this column to this value of 70. And here's what I end up with. For each row, it tells me whether or not this statement is true for that row or not. So it looks like the first house has a square footage that is greater than 70. The first three houses have a square footage that are all greater than 70, but the fourth house has a price per square foot that's less than 70. Okay, and if we come up here, we can see more than 70, more than 70, more than 70, less than 70. All right, so we're just taking these quantities and turning them into what we call Booleans, true, false values, and holding them like this, right? So this is what we're going to call our condition, right? This is what we're going to use to determine whether or not a home is in a high price per square foot category or a low price per square foot category, okay? And then we're going to use something called the .loc operator, okay? So the format here, it looks something like this. It's a little bit technical, so I'll try and explain this a little bit better, but we're going to take our data frame, small house, .loc, then pick the logical expression we're working with. Then we're going to give a new column header, and then we're going to do some assignment. So let me just walk you through this. So small house .loc, the .loc stands for location, right? So I want to know the location of all of the true values, right? In what rows did this evaluate to true? Okay, that's what I really want here. That's the location I'm interested in, is wherever we see these true values. Okay, so I'm going to pass that condition in here that has all those different true and false values. And I'm going to say, wherever that condition is true, make a new column called high price per square foot. Sorry about that naming there. Okay, and set everything in that column. If this condition is true for that row, then in this column, set that cell equal to 1. Okay, so we just made a new column, and we only have values where this condition was true, right? This condition right here. So we put a 1 here where price per square foot was greater than 70, a 1 here where it was greater than 70, a 1 here is greater than 70. Here it was not greater than or equal to 70, so we didn't do anything. So a nan got inserted, right? This nan got put in because it said, hey, you didn't tell me what to do if it was less than 70. You only told me what to do if it was greater than or equal to 70. So I don't know what to do for this row. I guess I'll just put a nan in, is what pandas did. Okay. So if we want to make sure that every cell gets filled, we need to actually have 2 different conditions here. We need to have a condition if it's greater than or equal to 70, and also a condition if it's less than 70. So I'll call this condition 1 and condition 2. Okay, and we also need to have 2.loc commands. We're going to set it to 1 if condition 1 is true, and we're going to set it to 0 if condition 2 is true. Right? Basically, I'm just putting zeros in where all the nans are. Okay. So now I have this indicator. We've made a new column here of 1s and 0s. It's a 1 if this is a high price per square foot home, a 0 if this is a quote unquote low price per square foot home. And we kind of picked this threshold somewhat arbitrarily, right? I could change this to 80 if I wanted. Okay. And the values here will follow suit. So now only these 2 evaluate to true, because those are the only 2 that are greater than 80. Okay. I'm actually going to put this back to 70. But yet again, this is a way of making a somewhat continuous variable. It can take on really any value, has all this decimal portions to it. And we have just taken this continuous variable and turned it into a categorical discrete variable. Okay, so we just transitioned between these types of variables, and maybe this will say something a little bit differently about our homes than this variable will. Okay. But this is another method of creating a new column on a data frame using .loc. So yet again, I'm going to say my data frame .loc, and then square brackets and some condition. My new column header. And then I'm going to assign it to a value over here, right? So this is kind of, this code will not run. This is what we call pseudocode, where I'm trying to just express in generic terms what the code is doing, right? Say, get the location where this condition is true, and wherever rows that is true for, take this column and set it to this value. Okay, we're going to practice this a lot. We're going to use .loc a lot over the coming days. So if this is still not 100% sunk in, we're going to talk about it in our Q&As. We're going to use it in lecture tomorrow. We're going to use it in a lot of different ways. All right. So assignment to a new column based on a condition. All right, I'll put that here. It's really what we're trying to do. Or let me put this in a little bit more plain terms. Assigning values to a new column based on whether or not a condition is true. Something like that. Hopefully that's a little bit more plain. So again, why might we want to have categories for a high and low price per square foot or cost per square foot column? In other words, why might this column be valuable to us? Any ideas?
We're gonna go rob them.
Yeah, there you go. Now you know which joints to case, right?
Well, maybe the real estate agent wouldn't want to, if you were, developing this out for a real estate agent or something, maybe they would only want to focus on the ones that are above 70 or above whatever value.
Okay, yeah, maybe you want the biggest commission. Maybe you are the real estate agent, right? And you want to sell homes that are expensive, so you get the biggest commission or something like that. So you can only work with so many clients, right? And so as Jerry says, you want to narrow your search down to only those homes that are gonna make you the biggest income. And these are the same kinds of considerations a business might have, right? They want to get the biggest bang for their buck, and they have limited resources, so they want to know where should we focus those resources, something like that. Right? Lots of ways that this might be useful. One of the biggest things is that we as humans, we're not good at keeping track of like lots of very different numbers, right? We want a general like threshold, like, well, is it an expensive house or is it not, right? That's kind of easier for us to reason about and think about. So maybe this kind of an indicator is going to make it easier for our human brains that can't comprehend 1,460 rows at once to think about these homes. So lots of different reasons, but to rob them, by the way, don't do this. To sell the expensive homes as a real estate agent. And another one is just for to simplify the way we think about the homes, something like that. Make it easier to think about them. So there's probably lots of even better reasons than these, but I just wanted you to see that those, even a simple variable or simple column like this can have its uses. All right. The next thing is going to get a little bit tricky. We are going to make a new column here, but we're going to use and or conditions in our statements. So I'm going to give an example, and I'll be able to explain that a little bit better. So we don't have any missing data in the square footage column, specifically in the basement square footage, right? So if I do small house total basement square footage dot is null dot sum, see, oh, there's no missing data in the basement column. Okay. However, if I do value counts here and I say ascending equals true, I'll say ascending equals false. Okay, you'll see that there's actually 37 homes with no basement square footage. So this means that there's probably 37 homes that don't have a basement. All right, don't have a basement. So what we're going to do here is we are going to make some new columns here based on those conditions. We're going to practice this .loc a couple more times. Okay. Yeah, get here into my notes so I don't mess this up. So small house, okay, then .loc, that's how we always start. And the .loc always has square brackets on it. Then we're going to put our condition in, our new column header, and then assign it to something. Okay. So one thing we're going to do is we're going to have a somewhat complicated condition. I want to look at small house, and I want to know, is this a high price per square foot home? I think that's what square foot. That's what I called it. Okay. And if that's true, then this should be equal to 1. Okay. But what if I only wanted homes where there was a high price per square foot and they had a basement, right? We want this to be an expensive home. And has a basement. Okay. So I say, I want this condition to include both of those things. I want to know where that's true and where we have a total basement square footage that is greater than 0, right? I want to have a basement and be high quality. Okay. Now this is my condition. Now, a couple of things here. First off, if I run this right now, it's not gonna do what I want it to do. Okay. It says the truth value of a series is ambiguous. You're like, oh, thanks, that's a very helpful error message. It's actually not. Okay. What this is saying is it's trying to compare a series, in other words, a column, to something else that it can't really compare it to. And the reason for that is it's looking right here in the middle and it's saying, hey, 1 and basement square footage, I can't compare those two things. Okay. So one of the things that we should do whenever we have what we call a complex conditional is take the two smaller conditionals and wrap them in parentheses. Okay. And that will help make it so that this expression doesn't get confused here in the middle by trying to compare the number 1 to a column of data and going, that comparison doesn't make sense. Okay, so that's step number 1. Make sure you wrap your two individual conditions in parentheses. Okay, and it looks like the first house here is a high price per square foot and it has no basement. Oh, excuse me, it does have a basement. We just wanted this to be greater than 0. Okay. So this is the condition. Nice house has basement. Okay, nice house has basement. That's my condition here. I also want a condition here for not nice house has no basement. Okay, so we want this to be a not nice house and to have no basement. Okay, these variable names are arbitrary. I'm just trying to make sure that you can kind of follow what they're representing here. Okay, so those are my conditions, and I want to make some items in a new column based on that. Okay, so we're going to say small house dot loc, and my condition is nice house has basement. Okay, if that is true, if it's a nice house and it has a basement, then make this new column called expensive basement. And set that equal to 1, right? Just say, yes, there is an expensive basement. Well, I want to do something for the other condition as well, right? So if this is not a nice house, I mean, you don't have to have a high price per square foot to have a nice house, but just go with me here. And has no basement, okay? So if this condition is true, then we want to set this equal to 0. Okay, we got some nans in here. Let me just double check this, make sure I didn't mess something up. Greater than 0 equals 0 equals 1 equals 0. Yeah, I think this is what I meant, what I intended. Okay. Another thing I'll point out here is that you do not have to save your condition to a variable. You could take this condition and put it directly inside the .loc. It just makes this line of code a little bit long. All right, so it's up to you whether you want to optimize for not having very many lines of code, or if you want to have for having very readable code. This does exactly the same thing. Okay, I can put the condition directly in, or I could save it to a variable and then put the variable name in. Same thing. Okay. So that's just another expression here, but we only wanted to set this value if both of these were true. Both of these conditions were true. We only want to set this if both of these conditions were true. What if I wanted to set this column equal to 1 if we had a high price per square foot or we had a basement? Okay. Right now I'm saying only do it if we have both. What if I want to do if we had either one? Well, I can indicate an OR statement by putting this pipe symbol here. So that's just above the return key. You do shift backslash, you get this vertical line pipe symbol. So the vertical line pipe symbol says this is an OR condition, and the ampersand says this is an AND condition. Okay. A little bit different than if statements. Okay. And it looks like this is true for one or the other of these is true for pretty much all of our homes, right?
I've got a question.
Mm-hmm.
So in the conditional statement where you had like equals 1, and then that first one, the nice house has a basement, and then you did less than 0 or greater than 0 rather, but you could use like the exclamation and equals for not equals, right?
Yeah.
You could use any of the
Yeah. So this is the not equals operator. So if the high price per square foot was not equal to 1, so because we have a binary variable here that can only be 1 or 0, this is the same as seeing equal to 0. Right? Because in this column, if it's not 1, it has to be 0. Yeah. So this is not equal to. So I could have done this. I want it to be equal to 1 in this column, and I want it to be not equal to 1 in this column. This will evaluate to the same thing as it did before. So yeah, there's multiple comparison operators is what they're called. Equal to is the double equal sign. Not equal to is exclamation point equal sign. And then we have greater than, equal to, less than or equal to, greater than or equal to. All right. So I could send greater than or equal to 0. Well, every house is greater than or equal to 0. Right? Anyway, so yeah, good question. And so again, not exactly Pythonic, right? There's multiple ways of doing things. All right. Any questions? Okay. We're going to take another quick 5-minute break. And when we come back, we're going to talk about the .apply function. Sorry, I'm trying to find where I was at in my notebook. And we're going to work with strings. So we're going to do kind of both of these objectives at once. We're going to use the .apply function to work with strings in pandas. So I'll see you back here in 5 minutes. All righty. Come on back. We'll get going here with the kind of our last section here for today, talking about that dot apply function, yet a third way of making new columns, right? So the first method we showed you was just using what we call those arithmetic operators to add together some numeric columns or divide the numeric columns. As long as those columns have floats or integers in them, we can just add them together, divide them from each other, right? And remember, using square brackets to indicate our new column header. That's method number one. Method number two is to use the .loc operator to conditionally assign values in a new column to a specific value. Method number three here we're going to go over is using the .apply function, where we're going to write our own little function that we know can work successfully on any given cell within a specific column, and then we will apply that function to every item in the column. Okay, so it's a little bit more complicated in what it's doing for us behind the scenes. We'll try and walk you through it. Okay, so we're actually going to use a new data set here, and this is the data set you are going to use on your assignment. So this is data from a company called Lending Club, where you can go and give loans to other individuals on the internet, peer-to-peer loans. Okay, as I read in this data, you'll notice we kind of got some issues. Right, first off, Pandas is trying to tell me that it's got a whole bunch of data type issues in these columns, and everything is bold. Like what's going on here? Okay. Well, I would like to show you that whenever we're reading in a data set here from a CSV, you can use something called the curl command to look at the raw file. Okay. So let me grab this guy here. And we're going to curl it. Binary output can mess up your terminal, blah, blah, blah. I don't want to output it to a file. Okay. Actually, the curl command's not going to work unless I do some other fancy things. So let's scratch this, because I don't want to distract us too much with this. Plus, we don't have too much time left. Let me just show you, if I can here, the file. Instead of opening it up in our notebook, we're just going to open it up on our regular machines. So again, I navigate to this URL. It starts an automatic download. This file's a little bit bigger. There's a lot of loans on Lending Club. So it's taking it a minute to even download. Okay. And let me find it here. Loanstats.csv. I'm going to open this with text edit. Again, you can open this with Notepad or any kind of text editor that you have on your machine if you're following along. Okay. First off, notice there's a lot of column headers. There's a lot of columns in this data set. Okay. But there's a couple of wonky things that are really kind of weird about this data. First off, every item in this data set is a string. Okay. Someone's put quotation marks around everything, even all the numbers. Okay. So that's a little bit weird, and that's going to cause us some issues in a couple of places. But the real big issues here is that we have this first line where someone has kind of left notes for other people at the beginning of the data set, right? Now, this is something that's common if the person who's creating this data set was working in Microsoft Excel. To them, it's not a big deal. Oh, put something at the top of the file, right? Leave a note for somebody else so they can find the prospectus, right? But that messes up Pandas. It makes Pandas think that, oh, this is the column headers. This is the first line in the notebook. And then everything else must be data, which is why really everything here is in one single column in our data set, which is why everything is bold, okay? So we want to skip that first row here. So we're going to read this in again, and we're going to use a parameter called the skip rows parameter. I'm going to say skip one of the rows. So don't start looking for the column headers until you get down to the second row here. And it takes a minute, but now it has skipped that first row, that prospectus note, and then it started after that. And we can see that the data is read in well now. All right, let's do a loans.tail here. And you'll see another issue. Okay. Wait, what's in these code cells? Total amount funded in policy code 1, total amount funded in policy code 2, and a whole bunch of nans. Like everything in these rows is nans. Well, again, if we go back to the raw file, you see that somebody also left some notes. If I can scroll down here, it's a pretty big file. Hope this doesn't crash Notepad. Notepad is not made to open large data sets. Oh, it took it that long just to scroll down to there. Maybe you'll just have to take my word for it. My laptop is humming, the fan's on so much, trying to just read this file in Notepad. Okay. Once this stops spinning, I will probably just close this out and you'll take my word for it. Let's do this. Let's just do that. Okay, so similar to the prospectus note, these two are lines of code at the very bottom of the file that got added as kind of a note. And typical Microsoft Excel users wouldn't think twice about this, but we as Pandas users, this kind of can mess things up, right? So if I do a loans.isNull.sum, right? I'm trying to count up the number of missing values. And then I say sort values. Okay. So this will sort this output based on the right-hand side. And again, we have 144 rows here and I'm getting the truncation. I actually want to see everything here. So I'm going to go and change my Pandas display options all the way at the top of my notebook. Okay. Way up to the top. Pardon my scroll. Okay. And I'm going to change this. Show me up to 150 rows, please, Pandas. Okay. Come all the way back down here. And you'll see that many of these rows have exactly 3 nans in them, exactly 3 missing values. You say to yourself, that's weird. This is oddly consistent that I don't have any columns of data that are completely usable. Every column has some amount of missing data. And this is maybe could have tipped you off that there's still some irregularities in this file. Okay. What we're going to do is we're going to skip the footer too. Just like we skipped that first line, we can also skip rows at the end. And that's commonly where you'll find anomalies in these data sets. All right, so we're going to skip rows and we're going to skip footer 3, I think. It's not liking that. Falling back to Python because of the C engine. So this is a warning, this parser warning. The C engine does not support skip footer. You can avoid this by specifying engine equals Python. Okay, we'll specify engine equals Python. Okay, we're still getting this error here. UTF codec can't decode this byte in some position invalid byte here. Let's see. Boom, boom, boom.
Yeah, Ryan, when I was working with it, I could never get tail to work with that like tar thing that we're reading in. It works just fine when we pull it, and they're gonna work with it pulling from the Lambda School repo, so it'll be no problem to do it in the guided project. I just need to not use the S3 bucket. It's something about that.
Gotcha. Okay.
Can't we just delete the last 3 rows though?
Yeah, that's actually what we're gonna do here. Let's just delete the last 3 rows here. So I'm not going to do the skip footer. I'm not going to do engine equals Python. We are just going to say that loans equals loans. So let's see. If we do a print loans.shape. Okay. So this is the number of rows we have in the data set. And I'm going to say, grab me everything from the starting row up to row, let's go to row 12 here. So we'll leave off the last 3 rows. Okay. So we should start off with loans being this many rows long, and then we're going to cut it down, and then it should be only 12 here at the end. Okay, so we have in effect just dropped the last 3 rows. I could have also dropped them individually by providing their individual row indices, but this is something we call list splicing. You don't need to really focus on that for today. Your data set will not have this problem. You're actually going to work with a smaller version of this data set because code grade actually can't handle processing your assignments if we give you the full version of the data set. So we're going to give you like a little bit of a pared down version here. Okay, so now if I do loans.tail, all right, and you'll see that those rows at the bottom are now gone. So there are ways we could have read in this zipped file, this tarball from the S3 bucket, and kind of unzipped it, uncompressed it to make it so that UTF error didn't come up, but not really a priority for today, right? We're focused on the learning objectives. So this will get us what we need to be able to at least work on this here during lecture. Okay. So again, now if I look for missing data in loans.isNull.sum, right, you see we have a bunch of zeros now because we removed those bottom rows. And so that's good. That tells us we have some columns that are complete and we can work without having any issues. Did I spell ascending wrong? Oh, I meant to say dot sort values. Call that function. Yeah. Now all those nans, we had 3 in each of these columns before. Now we don't have any missing data in any of those columns now. All right. However, there are some columns here where how much missing data exists in these columns?
All of it.
All of it. Every single row is nans. Okay. Why do you think that might be? That's some specific columns here, the ID, the member ID, the URL, the description. These columns are completely blank. So why has Lending Club included them in the data set if they weren't going to give us any of that data anyway? What do you think's going on here?
They probably extracted that stuff so it wasn't a security risk, right?
Yeah, good. So this is what we sometimes call de-identified data or sometimes anonymized data, right? Lending Club is saying to us, hey, we have this information about our users in our database. We're just not giving it to you, right? They don't want us to be able to, with the information in this data set, be able to identify a specific person, all right? You say you can have the data about this person, but I don't want you to know, oh, row 27, that's Bob, right? And here's Bob's data. They don't want us to be able to do that because then maybe we could take this data and go and steal Bob's identity or something like that. I don't know, right? It says, but it's for security reasons. But really, these 4 columns are not useful to us. They are completely blank. So we're going to just drop them. Okay, so you can see where we're using a lot of the things that we've talked about yesterday. So I'm going to drop a whole list of columns. I'm going to drop ID, description, member ID, and URL. Okay, and I'm going to do this in place. So it will modify my loans data frame directly, but I'm going to run this and I'm going to get an error. And ID, description, member ID, and URL are not found in the axis. This is a somewhat common error to get when you're dropping things. What's going on here? Why did I get this error?
That you got to put in that axis equals 1, I think, right, for rows, as opposed to the default is axis equals 0 or.
Yeah, good. So by default, .drop is trying to drop rows of my data frame. But I'm not trying to drop rows. I'm trying to drop columns. And I have to tell pandas, hey, I know your default is to work on rows, but for this time, please work on the columns, which is the 1 axis. So anything that is axis equals 0 operates on the rows, and axis equals 1 operates on the columns. And then we'll do a little loans.head here. Okay, and you can see the ID and the member ID columns that were all the way over here on the left, those are now gone. And we have 140 columns instead of 144 like we previously had. Okay. So this is, we haven't even got into making new columns yet. This is still cleaning our data, right? Still processing it with pandas here, but we've only got about 10 minutes left. So we'd better get to what we came here for. All right. We might go a hair over time here today. I'll try and not go long over. Okay, I ran this code cell again saying, hey, not found in the axis. Well, that's because I already dropped them. Right? I already dropped them, and then I ran this code cell again trying to drop them for a second time, and now they're not there anymore, so it's saying that it can't find them. Right? So if I wanted to, I could come back up and I could rerun these code cells, reread in the data set from the beginning, and then that error message will go away. Okay, so we want to clean up the int rate column. So I'll just look at the first 10 values of int rate here. Oh, this is called loans, not DF. And you'll notice the data type here is object. So it's seeing that these are string values. And we've got this funny % sign on the end of these. All right, we don't want that % sign on there. We want these to be floats, right? What if I wanted to calculate the average interest rate? Well, I can't do that if these are strings. I need these to be represented in a numeric fashion so that I can do some of that statistics stuff on this data. All right. Another thing I'll show you here is if I take the int rate column and just look at the first item in that column, you'll see that there's also a leading space in front of this interest rate. So it's not super clean. Right? There's multiple things messed up with this string data that I actually want to be a float data. Okay, so what we're going to do is we're going to make ourselves a little variable that we can use to test things out. Okay, I'm going to take this interest rate right here. If I can copy it. Oh, copy. And I'm going to call this my test case. Okay. And I'm going to say to myself, if I can fix this one interest rate, and I know that all the interest rates in this data set have the same problems, well, if I can do it to one, then I know I can do it to all of them. And that's kind of the approach of the .apply function, is write a function that we know can work for any individual cell. Okay, and we're going to kind of build up to this here. So the first thing I'll show you is that if we take our test case and say .strip, okay, then this will remove, I should do this down here. This will remove the white space. So it removes the leading space. This is the default behavior of .strip. If we don't pass anything into the parentheses here, it just removes white space. However, if we do pass something in here like a % sign, it will remove the % sign, right? So it's looking for whatever we tell it to at either the beginning or the end of the string. And if it finds it, it's going to pull it off, remove it. Okay. So with this line, we're removing the % sign. And with this line, we're removing the leading space. Well, we can actually do both at the same time. I can say, hey, please strip off the white space and then strip off the % sign. It's getting closer. It's starting to look more like a number, right? Okay, but there's still one thing that's wrong with this, that it's still a string, right? You can see the quotation marks around here, right? So we're going to do something called casting. And that means we're just going to change the data type of this thing, right? So right now, I'd prove it to you, right? This is a string, right? Use the type function. We're working with a string. Well, I can pass this string value into this float function, and it will get turned from a string into a float, right? 23.40 is now 23.4. Okay, so this line, I know, for if as long as the value of this variable changes to represent any item in that column, I know that this line of code will clean up those strings, turn them into floats, and make them usable values. Okay. So now we're going to do this with the whole column. Okay. One thing I can do here is I can say, take loans and then the interest rate column and say, hey, please, pandas, treat everything in this column as if it was a string. I'm going to call some string functions on this. So .str says to pandas, hey, treat this whole column as strings. And then I can say .strip, please strip off the parenthesis for me. Oh, and this needs to be a in a string. Okay, now we just modified the whole column, but it's still objects. These are still strings, right? So let's do .strip. Now the white space should be gone too. What is it not liking? Series object has no attribute strip. There we go. So we'll strip the %, then we'll strip the white space, but I'm doing this to the entire column. Okay, but it's still objects. And now I'm going to cast the whole column. So this uses a different function as well. I'm going to say as type float. And now everything is a float, right? So this line of code has just changed everything in the column. Okay, so this is one way of use the string and float casting functions, but do them to the whole column. Okay, we're going to use slightly different functions than we used above. str using .str.strip. Okay, that was a little bit different because we had to say, hey, please treat the whole column as strings before we could do .strip. And then instead of just using the float function here, we had to say .as type float to cast it to a float. Okay. So this is doing what we want. And if we wanted to, we could make a new column on our data frame called int rate cleaned or something like that, right? Say this is our cleaned up interest rates. This holds the values actually as floats, right? So where does that new column get added? It gets added all the way over on the right. So here's int rate cleaned and actually holds float values. Okay. Last but not least, we're going to use the .apply function. Okay. What the .apply function does is it's going to take a function that I provide and call it on each individual cell in the column, right? And so we already have the functionality written out to do this. All right. We already have this guy right here that we know works, right? Whoops. Right. If we can fix one, we can fix them all, right? But now we're going to take this functionality and we're going to put it inside of a function. So I actually don't need a couple of these cells. All right. So I'm going to make a function called clean the interest rate, right? I'm going to name the function something sensible that's descriptive of what this function is going to do. And this function is going to take in as an input each individual cell in a column one by one, okay? And then what it's going to spit out as its output is this expression, right? It's going to take those cell contents and fix them, clean them up, right? The thing is I need to take this cell contents variable and that's going to be what I'm actually stripping things off of and turning into a float, okay? So what if I take loans int rate? So here's the interest rate column of loans. And I'm just going to take the first item, the first cell, right? And I'm going to pass that to my clean int rate function. So I'm just grabbing the first cell in that column, passing it into my function, and look, it does what we want it to do. Okay. The reason why we might do something like this, take this functionality and hold it inside of a function, is whenever we know that we're going to be using a piece of code over and over and over and over again, we probably want to hold it in a function so that we can very easily call that function on demand and get that process to happen, All right. So because we're going to be calling this function on each individual cell in a column, all right, then holding it in a function is not a bad idea. In fact, it's a best practice. All right. We already went over some of this. Okay. So let's do this. All right. So below here as well, as something I'll just leave here for your reference, is kind of a review of the parts of a function. All right. Remember, we always start with the def keyword that says, hey, we're defining a function here. We're going to write our function. Then we give a function name. All right. This is the same name we're going to use when we call the function. This is any inputs that are going to come into the function. We call them parameters. And then we're going to return the modified input. So we're going to bring the input in, the cell contents. We're going to modify those cell contents in this fashion and then spit them back out. We're going to return them as the result of this function. All right. So different parts of a function here. The value that we return, we sometimes call this first line the function header. And then everything that's indented here, we call that the function body. All right. Terminology you don't have to have memorized, but that you may hear used by myself or by others as they're talking about functions. Okay. Well, all that I've done here is I've written a function and I've used it on one individual cell. What if I wanted to use that function on all of the cells in a column? I want not just one, I want to use it on all of them. Well, that's where the .apply function comes from. So let me actually copy this down. Okay. And I guess I should follow my own notes here. Okay. So here we've written our function. Man, it scrolled up for me. Here we've written our function. Here we've tested it out on just one of the interest rates, the first item in the column. And we can double check here that the data type is correct, right? It should be returning a float. And it is, it's returning a float. All right. So we are now going to apply this to every row. And this is going to be simpler than you think. We've already really done all the hard work. The hard work was writing the function that we knew would work on any individual cell in the column. All right. So what I'm going to do is I'm going to say, hey, take my interest rate column. Int rate, right? That's the column that I want to affect with this new function that I've written, right? I want this function to get called on each individual cell within this column. So I'm going to say, hey, take the interest rate column and apply the clean int rate function to it. Okay. And it will clean up the whole column. So it's doing a little bit of magic here for us. Behind the scenes, it's kind of writing a for loop and calling this function on each individual cell, right? And then saving that data back into this new column that it has spit out for us. Something I want to really draw your attention to is that there are no parentheses on the end of this function name, okay? I'm not calling this function. I'm just providing its function name into the parentheses here. That's all I'm doing, right? So this function that I know works for any cell in the column, please apply that to this column. Okay, and then if we want, we can make a new column here called int rate cleaned to, right? Something like that. This is the second time we've done this, but with a different method here. And once I've done that, this should exist all the way over on the right-hand side, right here. So we've now done this in multiple different ways, but with the same result, okay? I strongly encourage you, of all the methods we've talked about here, to focus on the .apply function because it's just a little bit more versatile. I could write a function that does anything I want. Anything I want, anything I could think up, I could write a function that would do it on any individual code cell and then apply that to the whole column. All right. And so the fact that I get to write my own custom function here gives .apply a little bit more flexibility. And I think is going to be the most powerful tool for you as you go to modify columns of data and create new columns of data, which we call feature engineering. Right. Any final questions here? You're going to practice all of these methods on your assignment. Sometimes you'll be specifically indicated, hey, take this column and use the apply function to change it. Now take this column and use .loc to make a new column, right? And you'll be told to practice those specific methods on your assignment. And we're just going to practice manipulating this data, cleaning it up, and making new columns, which you're going to do surprisingly often as a data scientist. Okay. Thank you, everyone, for your participation today. I'll have this video up to YouTube as fast as I can. I got a little bit behind. Everybody else's classes are trying to upload videos at the same time. So I'm going to try and be fast today and get to the front of the line. So that video is available this video is available a little bit earlier today. But again, there's all the previous recordings in Canvas as well in the meantime. So take a break for lunch and we'll see you back here in about an hour or so to dig into the assignment. And then we'll have our typical Q&A at 1:30 p.m. Pacific time this afternoon. Okay. Thanks, guys. Thanks for your participation. See you in a bit.